Let's take a look together at the substation single line diagram. Now, you've entered a medium voltage station, and here's the drawing layout on a large page in the station from which you understand what's called a single line diagram. Single line diagram? Here, this diagram is the drawing you see in front of you. And it's called a single line because our electricity, whether in generation, transmission, distribution, or even at your home, is three-phase. So you always see a bus bar as a single phase, you always see a breaker as a single phase, but in reality, it's three-phase. So here we call it a single line diagram, meaning I draw one line for you, any phase, and of course, they are all copy-paste for the other phases. The single line diagram consists of, as you can see, a bus bar. Here is a bus and here is a bus, both drawn for you on the same level. Naturally, what is between them is either a bus section, a dummy bus, a bus riser, or a dummy bus, or a bus riser. Nice, good. You will always find that they have drawn for you, or the most common in stations, is that they have drawn the incomer bringing power from above, and everything below that is going to wherever it is intended. This means the power source is drawn from above. Okay. The power source is drawn like this from above. And what about the rest? The rest is outgoing, just like that. Good. Before, you will find simply that you have your cable coming to you, and of course it enters into a breaker. Before the breaker, there is the earth switch, and in the end, it enters, meaning, well, this is not different. The incomer is the same as the outgoing. Single bus, single breaker, consisting of a breaker, and a withdrawable circuit breaker, like the diagram you see here, and with it, earth switch, and from above here, it comes from a transformer. In the previous stage, you had voltages like 33 kV, 115 kV, 110 kV, 130 kV, or 380 kV, and there was a transformer. This transformer stepped down the voltage from the normal level to what level? To the low level or the medium level, which is the medium voltage, and brought it here to your feeder. So this feeder is considered for you as what? A transformer incomer. Okay, and all the outgoing ones are circuit breakers, all right? And there's also an earth switch, circuit breaker, and withdrawable circuit breaker, and earth switch, and withdrawable circuit breaker, and earth switch. All right, the entire scheme you have will look like what you see here. Let's also see if we can read the details a bit. Yes, of course we can read them. First, you have this bus bar, which has a voltage of 13.8 kV per heure. All right, and it's labeled for you as bus 1. On the other side, you'll find 13.8 kVs as well, but it's bus 2, so you have two buses. 300 and 600 amps are rated. For the level and the well, this is crazy. It has a rating of 40 degrees Celsius, meaning this is the current it can handle continuously without experiencing thermal stress or overheating. The conductor material can withstand this temperature without melting, allowing it to carry the current continuously. This is why we refer to it as continuously rated at 40 degrees Celsius. All right, and the 25 kiloamp per 3-second rating means that in the event of a short circuit, this bus bar can withstand a current of 25,000 amperes passing through it for 3 seconds. For a duration of 3 seconds only. Anytime beyond the 3 seconds will cause the bus bar to melt. Of course, this applies to both sides. Now, if we come here, you will find that each circuit breaker has its rating written next to it. This one is 3600 amperes because it's the incomer. And here you have this outgoing one at 1250, this one at 630, this one at 630, and this one at 630. Oh, sorry, 630. Sorry, this is 630, yes, 630, 630, and so on. As you can see here, so these are the ratings of the feeders you have as circuit breakers. And of course, this is the air switch. Naturally, before and after each electrical cut, depending on the station where the event occurred, you might find it only after, only before, or both before and after. You will find the symbol that represents the current transformer, which is the current transformer. And after the circuit breaker, in the direction of the cable at the earth switch, you will immediately find the second type, which is the voltage transformer, and this is its diagram, which is the voltage transformer. Both are used so that if any of you are entering an interview or anyone wants to know about them and has no prior knowledge, you must know that this is the current transformer and the voltage transformer. They are used to reduce the values of voltage and current to low levels that can be handled by measuring devices and protection devices. Also, as you can see, this is the bus section, and here you have the bus riser. And what does the bus riser mean here? It means it is equipped with grounding to the outside and has current transformers installed on it. All right, engineers, very nice, very good. So what do you have here? You have your system. Engineer Rashad, can you tell us where the bus bar grounding is? Engineer Rashad, I'll tell you, it's simple. First, the bus bar on the right side, okay, its grounding is done through the bus earthing switch that is located on your bus riser. Correct. So the grounding of the bus bar, where do you place this grounding? You have two directions, one here towards the bus riser and the other here towards what? Towards the output of the bus section. Exactly. Place it in the output of the bus section, meaning the bus section cell itself. In the output towards the bus riser, in a cell like that, and on the other side, place it there. How can you place it there? You can place it through a feeder or the cell we all mentioned, the bus measurement, which is where you place the grounding. So, of course, this requires me to go into the details of the cells to tell you exactly where the grounding is located. All right, someone is sending a question in the chat. If you could clarify with a sign, here you go. Engineer, what? At your service. This is the bus bar exposure. This is the bus bar exposure. And this is the bus bar cutting, but this can't be both. I mean, if one is present on the next bus riser, it can't be placed on the bus section. So surely this also has its own feeder, which we call the bus measurement that I mentioned to you. It consists of a cell, and this cell is a piece of bus bar, but it includes grounding and a voltage transformer. We call it bus earthing measurement, meaning it is referred to in stations as bus earthing measurement, and it is written like that on it. Okay, let me write on the text like this. It talks like this. Look, okay, that's very nice. Of course, with the difference in what it's called between one place and another, Maybesh and Wansin, my heart is good, so what are you doing? This single line is ahead. So what did I benefit from knowing? By God, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and of course this is 14, and the riser is 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, plus the reports, that's 28, meaning you have a feeder in this station regardless, maybe 2 incoming and the other 26 outgoing. No, not all 26 are outgoing. There's 1 riser, 1 section, and just 1 measurement. So 3 out of 26, leaving 23. So what could these 23 be? Are they all going to feed loads? Not necessarily. All of them are going to feed loads. Some of them might go to a capacitor bank, like the example we will take. One of them might be going to a luxury transformer to feed substation services, which are the station services. One of them might be going to a meter divider, which is connected to another switch here, and so on. All right, great.